Some Algebra 1 work, and we're going to just talk about graphing an inequality in one variable. So if I think about inequalities, they're not necessarily equal, they're inequality. So could be equal, but not necessarily. So I could have something like x is greater than 3, or x is less than -5. And I could also have some statements where it's not just strictly greater than and not just strictly less than. I could have things like x is greater than or equal to 7. Let's just make this -7. Or x is less than or equal to 5, say. Something like that. So notice each of these are talking about a relationship between x and a number. This is saying x is greater than 3, right? It's pointing toward the smaller one. It's more open to the one that's greater. So if x is greater than 3, if I think about my number line, let's put 3 there. That means 4 would be here and 2 would be here. Notice that like 4 works, right? 4 is greater than 3. And actually anything bigger than 3 would work, but 3 itself does not work. 3 is not greater than 3. So the way that we graph that is we do an open circle at 3, and then we shade the side where all those numbers work. There's an infinite number of numbers here, right, that work. 4, 4.7, 18, 5,000, 3.1, 3.001. What the open circle tells us is that we can get as close to 3 as we want without actually touching 3. 3 is the boundary, but the boundary is not part of the solution. If I look at this next one, x is less than -5. So if I put -5 here, -4 would be here, -6 would be here, that's a 4. And it's not equal to -5, so I'm going to put an open circle there, showing that's the boundary, but the boundary is not part of the solution. X is less than -5, so it's going to the left. All of these values that are less than -5. A couple more here. I've got this with -7, and I've got this one with 5. So x is greater than or equal to -7. So let's mark -7 here. I'll put -6 here, -8 here. But now, when it has this line under it, this means x can be greater than or equal to that value. So if x can be -7, I'm going to close up that circle, and x is greater than it, so everything to the left. Similarly, with this one with the 5, 6 would be here, 4 would be here. X is less than or equal to 5. So close up the circle. The boundary is part of the solution, and x is less than, so it's everything to the left of 5, including 5.